So in the last two sections, we have covered the parts importing the libraries and importing the data set. Now we will move to the next step of data preprocessing, which is checking out the missing values. So let's understand what is that first. So let's go to our data. Let's look at our data set. So here, as you can see, for the set of independent variables, that is age, gender and income, we have few missing values. These missing values are denoted by NaN, N-A-N. So see, for age, we have this missing value here, here, here. Similarly, for gender, we have a missing value here, and we have a missing value here. So basically for this customer number 8, we don't know what his gender is. And similarly for customer number 3, I don't know what his gender is. For customer number 4, I don't know what is his age. Similarly for customer number 7, we don't know. Then for customer number 1, we don't know what is his income. So these are certain missing values in our data set. Now while working on any machine learning problem, it is very important to treat these missing values. And there are various strategies to do that. Now one very simple way is that we can remove the records which have missing values. So basically we will remove customer 1 from our data set. We will remove customer 4 from our data set. We'll also remove customer 3 from our data set. Then we will also remove customer 7 from our data set, customer 10, and likewise. But removing the missing values is not a good strategy, as it will result in losing a lot of information from our data. Basically see, here we have records for 15 customers. Now from out of 15, if I will remove around 8 customers already who have missing values, I will lose a lot of information about this data, and then basically I'm removing 50% of the customer records. So basically we will remove a lot of records from our data, and that won't result in a good machine learning model. So we don't use this approach generally. There are various other well-defined approaches to handle missing values, which we will understand in this section. So we don't use this approach generally, as it comes at the price of losing data. So a better strategy is to impute the missing values, which means to infer the missing values from the known part of the data. What I mean by this is, now see, for the age column, we have few missing values here, 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 but we have a lot of known values as well. So what we can do is we can infer these missing values from the data which we already know. So one simple way is to take a mean, an average of the known values, and replace the missing value by the mean of the known values. Here we can take an average of these values: 25, 36, 41, 52, 29, 48, 27, 31, 45, 52, 33 and 44. We will take a mean of these values and replace all the missing values by the mean of these known values. Similarly, we can do this here for income. So mean is one such strategy. We can also replace these by the median or the mode, or by various other ways. So these are some sophisticated methods we use to handle missing values. We also need to replace the missing values in the gender section. Right now, these are categorical values. So we will first learn how to handle categorical values and then replace these missing values accordingly. First, in this section, replace the missing values in the age and income section, which are continuous variables. Let's learn how to use these methods for handling missing values. So to do this, first we will name this section as handling missing values. And now we will use a library to do this data imputation. So we will write from sklearn dot impute import simple imputer. I will just explain what we have written over here. So sklearn is scikit-learn here, and from it we are using the impute library, and from this impute library we have imported the simple imputer class, using which we will handle our missing values. Okay, so now that we have imported the simple imputer class, we will create an object of this class. We'll name this object as imputer equal to, so you can name it as anything. Since we are imputing the missing values over here, I have named it as imputer. So we'll create an object of the simple imputer class. We have named it as imputer equal to, then we'll write the name of the class, which is simple imputer. Now the best way is to see the documentation of this class so that we will understand what parameters we need to input over here. So we'll go to help over here and we'll type the left parenthesis. Once we type this, a left parenthesis, which is a shortcut for getting help spider. If this part is not active in your console, then just go to tools, go to preferences, go to help, and then just select this part. So this pane can automatically show an object's help information after a left parenthesis is written next to it. If the editor and IPython console parts are unchecked in your spider, then just check them and click on OK. Once you do that, you will automatically see the help section of that specific class. So this is our simple imputer class, and these are the parameters listed over here that are to be used in this class. Just notice that these are the different parameters: missing values, strategy, fill values, verbose, copy boolean, add indicator. Not all the parameters are necessary. There are few parameters which have to be specified and others are optional. So for example, you can see missing values. We have to specify this parameter, and the parameter strategy is optional, and the default value is the mean value, which is the average of the other values. So if we don't mention any strategy, it will take the mean of the available values and replace the missing values by the mean value. And as you can see here, there are different strategies available: mean, median, which will replace missing values using the median along each column. And obviously it can be used only with numerical data. Then there is most frequent, and then there is constant. So we can replace our missing values with a constant value. So if we don't specify a strategy, then it will take mean by default. And if we want any other strategy like median or most frequent or constant, then we have to mention our strategy in our parameters. Other parameters are also optional and we don't need to enter them in our case, at least here. When you go down, you can also look at an example of how to use this class. So you don't need to memorize how to write your code while imputing missing values, and these examples are always very helpful to just refresh your understanding. We'll get back to creating our object, and what we will do here is, in the simple imputer class, we will first mention the missing value parameter. So we'll write missing underscore values equal to, now it can take a number, string, and np.nan, which is a default, or none. So in our case, we'll mention missing values as np.nan equal to np.nan, comma. We will also mention our strategy equal to mean. Now, as I told you, if we are giving mean as a strategy, then it's not a compulsion to mention it over here because it takes mean as the default value. But still, we are mentioning it over here so that we can even change it later from mean to median or most frequent, etc. So now that we have created an object of the simple imputer class, so now we have created this imputer object, and the next step is to fit this imputer object to our data frame of independent variables, which is X over here. So what we will do is we will type imputer dot fit parenthesis. So as you can see here, the documentation for fit has come up over here, and it says it is used to fit the imputer on X. This is what we are doing here. We are fitting this imputer object on our data frame of independent variables, which is X. So we'll type X over here. One thing which we need to notice over here is we are only replacing missing values for age and income column. The gender field is categorical for now, and we will handle its missing values in the next section when we will understand handling categorical values. Now we are imputing missing values only for age and income, which is our column number 0 and 2. So we won't select all the columns over here. We'll select only column number 0 and 2. And to do this, we'll type dot iloc brackets all rows, comma, again brackets, column number 0 and 2. So as you must have noticed here we cannot give the range 0 to 3 because we don't want to select the column number 1, which is the gender. So we only want to select column number 0 and 2. And to do that, we'll put a bracket here again and specify the exact column names which we want to include. So once done, this is nothing but our imputer object only, which has been fitted on the column number 0 and 2 of our data frame independent variables X. So we'll again name it as imputer. So by writing this imputer equal to imputer.fit and this part, we have basically fitted the imputer object on our data frame X. And now we just need to replace the missing values in age and income section by the mean values. So to do this, we will type X dot iloc. So basically type this same thing over here. So I'll just select this part and paste it here, equal to imputer dot transform parenthesis. And as you can see here, the documentation has come up for the transform method. So it is what it does is it imputes all missing values in X. This is what we are doing here. In transform, the parameter that we have to enter is X, which is our data frame basically. So I'll again copy this part and paste it here. Column number 0 and 2 in our X data frame will be transformed with the mean values of the available data. So our code is ready. We'll just select it and press Ctrl Enter. And as you can see here, it has run properly. Now just press X here and press Enter. So as you can see here, all our missing values have been replaced. So this 38.5833, it is the mean of the available age values, and all the missing values have been replaced by the mean over here. Similarly for income, our first customer's income was missing, as we can see here in our data frame. For customer number 1, the income value was missing. It has been replaced by the average of the all other available values, which is 48357.142857. So congratulations, we have learned how to successfully handle missing values in our data set.